Welcome. Thanks for joining us. I'm Mark Hannon from the City of Charles Sturt, and we're really excited to bring you this series of webinars that we've called Bite-Sized Bees. We're kicking off this four-part series on the history of the honeybee today. It's in recognition of World Bee Day, which is all about spreading awareness of the significance of bees and other pollinators and why they're important for our survival, as well as highlight the important role that they play in our world. This is our first foray into online webinars, so hopefully everything goes smoothly and you love what we have to share with you. Bear with us, particularly me, if we're a bit clunky in our delivery. We just hope all goes good and you enjoy it. At City of Charles Sturt, we've worked in partnership with our webinar presenter, who is Sandra from Adelaide Bee Sanctuary, for 5 years now, and we host a number of beehives across our community gardens and community centres. We're really excited about our latest project together, which is a see-through glass observation hive. We're building that in the Civic Library at Woodville. So if you've been able to go in there in these recent times of reopening, you will have seen that work in progress. We'll tell you a little bit more about that in upcoming episodes. For now, it gives me great pleasure to hand over to Sandra from Adelaide Bee Sanctuary for episode 1 of Bite-Sized Bees. I will just go to black and mute, and then Sandra will reappear seamlessly.
Hi everyone, my name is Sandra Ulrich and welcome to Bite-Sized Bees. I'm the founder of Adelaide Bee Sanctuary, and today we're going to present bite-sized information that you can share with your friends about the evolution of bees, their sensory world, and the amazing wax production factory that they are. So do enjoy and post any comments or questions that you have on the chat. So, about 100 million years ago, plants that produced flowers became the dominant type, and much of the evolution of their pollination systems occurred then. So social insects such as the honeybee also appeared. And social insects are those insects that live together in a colony, 10 to 20,000 insects, and they have forages that they send out to collect nectar and pollen, and they store these. So the image that you see here is of 2 fossilised flowers with stamens on the right-hand side of the image. And this is the type that was foraged on by pollinating insects. And this was found in the southwest of North America about 50 million years ago. This is an image now that you see of a fossilised stingless bee, Trigona prisca, and it was found in New Jersey amber about 80 million years ago. Now, it's thought that the stingless bees were the earliest of bees to have branched off from its less social ancestors. And the stingless bees then developed these highly social behaviours, and these bees particularly are confined to tropical regions around the world. The honey-storing bumblebee and the honeybee that we now are familiar with emerged sometime after the stingless bee, and some species of both the bumblebee and western honeybee are successful in temperate regions. So the bee, or genus Apis, diversified into several branches, of which we have Apis mellifera, which is the western or European honeybee, and Apis cerana, which is the Eastern or Asiatic honeybee. And here we have an early fossil of a honeybee found in Germany about 50 million years ago. So when I talk about the honeybee in bite-sized bees, I'll be specifically referring to Apis mellifera, or the Western or European honeybee. And those are the bees that you can see at local community gardens run through the City of Charles Sturt. So the honeybee has been the most important bee in man's history. And here we have an image of what? We've got a bee. We've got bright orange pollen on her hind legs, a bright yellow daisy, blue sky, green foliage, and a structure of a building in the distance. So how does the bee see its world? Bees can see colour, and they're superbly adapted to the signals transmitted by flowers. Their innate sense of colour, their ability to learn from experience, and the ability to then communicate this information form what beekeepers term as the basic triangle of bee wisdom. The visual system of bees, however, differs from ours in many ways. So, for example, we've got 2 bees here. The drone on the right has very big eyes to help him find that luscious, gorgeous queen up in the sky to mate with. And the worker bee, the female bee on the left, which has narrower eyes. So let's focus on the female worker bee who has 5 eyes. 3 smaller ocelli eyes that are sensitive to light and can see UV light, and the 2 larger compound eyes on either side. And each of these compound eyes is has about 6,000 single eyes to it. So for a worker bee, remember that picture I showed you where that bee was sitting on the daisy? The picture of its surrounding is put together from many quite large, separate, single dot points. Okay, so the poor optical ability of bees means they can only resolve the fine details of objects, such as flowers, when they're only a few centimetres away. So bees need to inspect things about 5 centimetres before they're actually able to recognise what that blob in the landscape is. And as you can see, the top of the image, it's quite far away. As the bee moves closer and closer to the flower, its resolution becomes clearer. Also, bees are not sensitive to red, which is compensated by the gain in sensitivity to short wavelengths of the visual spectrum. So bees can see ultraviolet light. So up here we can see red poppies that we're familiar with, but a bee actually sees it as black. And the petals of many flowers have some surfaces that strongly reflect ultraviolet light, pardon me, and form a pattern for bees which is invisible to us, but helps bees to sort of discriminate between lavender blossoms and cherry blossoms. And bees also use the short wavelengths of ultraviolet light that is emitted by the sun to help them with their orientation flights. This is really interesting. In terms of what the bee does, that affects how it views things. So if a bee is flying across the landscape to that field of yellow daisies that you saw previously, it sees in colour vision, okay? But when they fly back to their hive, they are effectively colourblind. They're only seeing black and white. So it really depends on what task that they're doing that influences the type of colour vision that they have. Bees are also sensitive to motion. So big flowers that are sort of on thick stems attract more visitors. So what happens to the little daisy that's on a very fine stem? Well, it's on a very thin stem, it's in the air, the wind is blowing the air, and that motion will also attract bees. So that is an interesting bit of information that I came across. Bees also have a highly developed sense of smell. So they, unlike vision, bees can be lured to a field of daisies from a considerable distance away. And also, if they're unsure of where that field of daisies are, and they've been exposed to the nectar and the pollen and the scent of the daisy from another foraging bee inside the beehive, they go out into the field and they can't quite spot it. They'll circle the air until they pick up that smell of the daisies, and that'll lead them to where that site is. And the final thing I think that I have here is when bees come to a field of daisies, how do they know which flower has nectar in it, which flower has pollen in it? I mean, are they going to go to every flower and try it out? No, bees leave little post-it notes on the petals of flowers. So I'm a bee, I come to a flower and I'm collecting the nectar and pollen and I'm leaving a post-it note there. And who have we got on? We've got Janet online, and Janet comes along and she sees the post-it note and she goes, wow, I don't need to go here. I'm going to go straight away to another flower where there's no post-it note. So that makes pollination and of crops highly effective for us. We rely on bees for our pollination, but also effective for bees in terms of getting the nectar when they're out there, and rather than having to check every flower one at a time. So I'm going to jump back to history a little bit. We know about Apis, the bee, the genus term for the bee, which lasted from about 56 to 33.9 million years ago. But that genus diversified into several branches of bees. And the 2 earliest branches lived in the tropics. These are the very small honeybees, or Apis florea, or the red dwarf bee, okay? We also have the black dwarf honeybee as well. So as you can see, they form a single comb, usually in the outside. And the larger honeybee, Apis dorsata, or the giant honeybee, again, as you can see on the right-hand side of your image, has a single comb. The third later branch included Apis cerana, or the Asiatic honeybee, and Apis mellifera, which is the European honeybee, which are intermediate in size, and they build multiple layers of comb in a cavity which needs to be about 40 litres in size, and they can live outside of the tropics. So mankind generally paid most attention to the nests of prolific honey producers like the European and Eastern honeybee. So the question is, why, unlike their outdoor single-comb relatives, were both Apis cerana and Apis mellifera able to inhabit areas of the globe where external temperatures are very, very hot, really, really cold? It comes down to their ability to produce wax, build multiple comb, and regulate temperature in their colony when they reside in a cavity. So let's explore that a little bit more. So here we have comb. When a beekeeper talks about comb, this is what they're referring to, made out of wax. And it plays an integral role in the bee colony. And its significance in terms of structure is very different to how we imagine shelter. For us, it's a house, and we build the house with bricks and clay or timber. But the comb for the bee is also a sensory part of who they are as a colony, because it's their skeleton, it's a sensory organ, the nervous system, memory store, immune system, and it's part of that superorganism as a whole. So bees and comb are inseparable and bound to each other in terms of survival. When a beekeeper talks about honeycomb, it's when the wax is filled with honey. Bees spend more than 90% of their lives within or on comb, and its ability to channel material, energy, and information in the hive. So again, without this, bees would cease to exist. And bees, the comb contains more than 300 different chemical components, which when mixed results in a substance with physical properties like liquid, even though it appears solid at lower temperatures. So when you're chewing on honeycomb, think about all those lovely chemical components that are in there. But this is the amazing bit. The honeybee belongs to an elite animal because they can produce the material required for the construction of their home. Wax is produced, as you can see on the slide here, there's little white sheets from 8 groups of glands in the pairs of the ventral side of the last 4 segments of the bee's abdomen. Wax scales are collected from by the hind legs, taken to the bee's mouth, and they chew it with their mandibles. And when they do that, they also secrete wonderful properties from their mandibular glands. And they bring this together to a consistency with which they then can work. And to construct an entire comb in a new nest, bees must invest in a considerable amount of energy. So for about 1.2 kilograms of wax, bees need about 7.5 kilograms of honey. So remember, when you're buying honeycomb to eat, the price should be reflective of the energy expenditure that bees have put out there. Studies in comb geometry has confirmed that here is a structure of unbelievable precision. Okay, the thickness of the individual cell walls is exactly 0.07 millimetres. The angle between the smooth walls is 120 degrees, and the comb hangs vertical. And the distance between the neighbouring parallel combs is about typically 8 to 10 millimetres, and that allows the bees, just like you see on the image here, to walk back to back against one another. And how do bees build comb in dark cavities? I mean, where's up, where's down, where's left and right? Well, they have sensory hairs on all their joints, and these are stimulated by the force of gravity. So the functions of comb is it provides shelter, a place to store nectar, produce honey, a place to store pollen to feed the baby bees. It's a nursery, telephone system, a dance floor, which we'll be exploring in another episode. Information storage, it's a first line of defence against pathogens, and it's also involved in temperature regulation. And here I come to another important sense organ, the bee's antenna, which helps the bees understand their spatial awareness, but also sensing temperature fluctuations. So researchers locked off their antenna and found that when bees had their antenna removed, the comb is in all different shapes and that bees are insensitive to temperature. And this is amazing again. I get excited about the heater bees, but here, in order to survive the cold temperatures, so Apis cerana, Apis mellifera, they can survive in incredibly cold temperatures and rear their young. They need warmth. They need about 37 degrees inside the hive. And they do this by metabolizing their energy, which is the rich carbohydrate that comes from honey. And they warm themselves by shivering with their flight muscles. And bees can increase their temperature to over 43 degrees Celsius. Geez, I'd melt if I did that, but 43 degrees Celsius. And the special subset of bees are called the wonderful heater bees. So they are darling bees. They come, they press their thoraces down onto the cell cap that lays between them and the baby bees, and they bring that warmth to the cell cap. And they do this for 30 minutes, and they remain completely still and move that temperature through to the pupa cells. They radiate warmth from all sides, and what happens is those bees that are passive and that aren't heater bees, they come close to these heater bees to make sure that they insulate and keep that heat in, so that passive insulation. And here's an example of brood cells underneath those golden caps of developing baby bees. Okay, so you've got an image here, but can you notice there are a number of little holes in there? 5 to 10% of the cells are empty, specifically designed for heater bees. They go in there, they lay their bodies in there, and they transmit that warmth. After 30 minutes, the heater bees are absolutely exhausted, so they need to require a bit of filling up. And I guess they've got some filling station bees. They come along, they feed the heater bees more honey so that they can continue that cycle. That also means that the heater bee doesn't need to leave those little holes, go and find the honey store and then come back again. So again, it's a wonderful way of avoiding interruption to heating activities. So how amazing is that? And here are the references. I've got Crane, and I've also got a book by Touts, wonderful references that you can look at and find more information about all of this. So thank you so very much. Any questions, do contact me. Lovely.
Sandra, keep staying there. We do have some questions. Excuse me, chatting off screen. Hello again. So we have a question from Kelly. She would like to know if bees have a favourite colour.
So bees' favourite colour, generally the lilacs, the purples, the blues. That being said, I've seen them on practically anything and everything, but they do favour the purples and the blues, yes.
Excellent. And then we have another question from Nell.
Mm-hmm.
What is the lifespan of a bee?
The lifespan of a bee is about 5 weeks. That is generally in summer times. Winter time, the bees are flying less, so it might be a little bit more.
And is that every bee will live 5 weeks?
The
queen?
The queen, she can live up to 4 or 5 years, so she has a longer life.
And why does she get to live longer? Do we know?
I think it's because she has been fed royal jelly early in her life. But yes, I actually don't know why she would live longer. They will supersede their queen if she's not up to standard. But yeah, she lives 3 to 4, 5 years, depending on her general overall life.
Jennifer, thank you, has said great presentation. Well done, Sandra. Can we have the notes of what was taught here? Some terms were technical and couldn't get it in one go.
Okay.
We're putting the presentation, after this is all done today, we're going to be, this is all being recorded,
yep,
and it will go up on our website, so we'll be able to play that again at whatever speed you need, Jennifer, and you can rewatch it. Hopefully that's okay. And then Another question is, do bees have a family structure? Do they have brothers and sisters, for example, or are they just one big mass of bees?
They are one big family, so that, they're all related. So they're all sisters. They have their brothers, which are drones, but they're all related. They might have visiting bees from another colony that is of a different family, and they come in, but they're all related. They're all born from the eggs laid by their mother queen. So.
And then we've got lots of questions. It's so good. Thank you, everyone. Another question is, are there some general flowers that I can plant for bees to forage year round?
It's a year round. What I would suggest is
plant lots of different things.
I think so.
Why limit yourself to one?
If something that's drought tolerant. I mean, sage, the lavenders, the rosemary. Letting your herbs go to bolt, so let the parsley bolt. Look at the sour sobs, they're out, allowing them to actually blossom. They come at quite a critical time and yield quite a nice nectar load for bees. The daisies, even your dandelion, people used to grow dandelion instead of lawns. That's an important part. So having diversity in your garden is really important.
And even weeds can be good.
That's it, yes. A dandelion, you've got those, and soursop's, I mean, the bees love it, but we look at soursop's and the first thing we want to do is snip or remove them by other means.
We do like to be a bit too tidy in our gardens. And then another question, this might be outside of your realm of understanding about native bees, but Sasha has asked the following question. She said, in the last few weeks, I've hung up a pre-made bee hotel in our garden, but it's yet to see any activity. Is there something I can do to help encourage the use of it?
So is it hanging and swinging like a pendulum, Sasha? That's the thing. I think if you could have it stationary so it's not moving, and the least amount of activity around it. I mean, our native bees are solitary and they like a quiet space.
And it's not moving.
It's moving, okay.
It's not moving.
It's not moving.
I think, Sasha, sometimes patience is a good thing.
Patience and not a lot of interruption, so you don't want it somewhere that it's not visited so much, and planting those plants and flowers around the place. And, patience.
Yeah, and I know for myself with the bee hotels that council built, generally once we go through a summer, you'll see them on the other side of that. Yeah. Then we have a question from Janet. What else is good to attract and keep bees in my garden?
Well, water source is a great thing. I think everyone can remember that 47-degree day that we had, I think it was last year or the year before, where Adelaide literally melted, and having a bird bath with a constant water supply with pebbles in there will attract not only bees, but, our native wasps, birds as well, butterflies, and even dragonflies. So having that is important. Flowers of a different variety, and
And then I think that's all of our questions. Someone has very nicely written too that they love your bee outfit, Sandra. So clearly the jewellery for World Bee Day has struck. Yeah. Another late question. What about the little bee homes from Bunnings? Are they worth putting in my garden?
Kelly, I think bees need to keep warm. So one of the things that I'm a big advocate of is if a bee hotel is made, like the City of Charles Sturt has these massive constructions, and, they're almost thermo-insulated themselves because they're big and they're robust. If you have just a little wicker one with cane, it might not be enough insulation for a native bee that generally might burrow under the ground where there's clay and there's a bit more insulation. So if you do buy one, provide it with a little bit more insulation as well, I think, which would help. Yeah. Right. So, it's a good start.
Now, I see the time is getting close to finish time. If everyone's happy, hopefully they are, then make sure you let council know, because we've got 3 more sessions to do.
And any feedback,
give us that, because, as I said, this is our first time out, and maybe my disembodied voice is distracting. Maybe it's better over here. Yeah. Who knows? But give us that kind of feedback. It's really important for us, because we will do another one of these on Friday. This is episode 2. There's another one on Monday. surprisingly, episode 3, and then a final one on Wednesday, episode 4. So if you've liked it, tell your friends. If you didn't like it, tell no one. And hopefully it's been really good. And I will attempt now to do a seamless finish to the show. So thanks again, everyone. And hopefully join us again on Friday.
Lovely. Cheers. Bye.
Bye. And happy World Bee Day.
Yeah, happy World Bee Day.